Call Marisha. I open the screen, share screen. Um, let's see. I'm trying to open the. Where do I click? Where is it? Um, just a second. I'm just trying to share. Um, what do you click the entire screen? Where do you click? Check. You're sharing screen. Okay. This is paper one. And we're going to look at the calculus question. Sorry about that. Question 7 is based on calculus. The first question is find the derivative from first principles. Given f of x equal to 2x squared minus 1, find f prime x. Oh, God. No. No. Okay. You're given f of x equal to 2x squared minus 1. It is useful to number that as 1. Find f of x plus h, which is 2 into x plus h all squared minus 1. Call that 2. Subtract the 2, that's 2 minus 1. That is f of x plus h minus f of x. And if you simplify that, you'll get 4x h plus 2h. Now, if that expression is divided by h, limit h approaches 0, that will give you the definition of f prime x. So f prime x is equal to f of x plus h minus f of x over h, limit h approaches 0. Now, please write the limit h approaches 0 on the right-hand side, next to the expression f of x plus h minus f of x over h. Now, when you simplify that, you'll get f prime x equal to the limit 4x plus 2h as h approaches 0. You substitute 0 for h, and your final answer is 4x. Students, I just advise you to practice a few examples and you'll be fine. Now, that is finding the derivative from first principles. Then you get various rules of derivatives. The first rule must remember that you must find the derivative of individual term. But if you add 2x plus h to the power 3, for your study in high school, you must first expand and then find the derivative of each term. At university, you'll be taught the different rules, chain rule, power rule, quotient rules, etc. But for now, remember The rule is find the derivative of each term. And also notice the notation d dx and the bracket. There's no equal sign there. If you got the expression f of x equal to something, then it is f prime x. If you got the expression y equal to 3x plus 4, etc., then it's dy dx. So you'll get used to the different notations for the derivative. That's one. Secondly, you need to simplify the term before you find the derivative. Example, the fifth root of x squared, which is x squared to the power 1/5, which is x to the 2/5. Now we find the derivative of each term. On the right-hand side, I simplify that. And so that will give you 2/5 x to the power 2/5 minus 1. Now, sorry, you'll notice that the 2/5 is missing there. You can write that down. And the derivative of 3 of x cubed is 3x squared. So far, so good. These are just warm up, and you should be able to work them out and get full marks. The next question is find the derivative of 4x squared minus 9 over 4x plus 6. Now, this is of the form a over b. It's a quotient, and you were not taught to find the derivative as it is, so you simplify. Combination. Right, when you simplify that, and the basic simplification here is factorization. If I want to scroll down here, what happens? I'll leave it. It's okay, I'll manage. Right, so 4x squared minus 9 is the difference of two squares, 2x minus 3 times 2x plus 3. The denominator 4x plus 6, 2 is a common factor, 2 into, yeah, there's something missing. 2x plus 3, the 2 is missing, and you cancel that out. So you're left with x minus 3 over 2, dividing 2x plus 2x minus 3 by 2, you get x minus 3 over 2. And now you write the derivative in the final step. So these two steps means you're simplifying before you find the derivative. The derivative of x is 1, and the derivative of minus 3 over 2 is 0. The derivative of a constant is 0. Now, I just included this example as practice for you. And it may be useful for you to have a pen and paper handy so you can write and you can note certain things and you can also ask questions. Now, you want to find dy dx given 3xy equal to 18x cubed minus 6x plus 1. Now, before you find the derivative, you must make y subject to a formula because you want to find dy dx. Therefore, you divide each term by 3x. Each term, so that's 1, 2, 3, 4 times. So you could divide each term by 3x, and that will give you, on the left-hand side, y equal to 18x cubed divided by 3x minus 6x divided by 3x plus 1 divided by 3x. And then you can find the derivative. Okay, so the first few questions are basics, and I'm sure you will manage and do well. The next question is question 8. Please take time, students, read the question, read it a few times, understand, analyze, and then tackle the question. Now, this is a cubic function. the graph of g of x equal to ax cubed plus bx cubed plus cx. Now, if you look at the graph, it passes through the origin. The origin is a y-intercept 0, or the origin is at point 0, 0. We also notice that at x equal to 2, there's a stationary point which is a maximum. And at x equal to -1, there's also a stationary point which is a minimum. Let's try and answer a few questions there. For which value of x will g increase? Right. We usually start on the left-hand side, extreme left-hand side. You take a point on the graph, and as you come down, the y values decrease. And you see it'll go below the x-axis where the y values are negative. And then you come to the stationary point. From -1, let's see what happens. The y values increase. And up to the point where x is equal to 2. Therefore, the function increases from -1 to 2. And you write your answer. -1 is less than x is less than 2. You can also write your answer in interval notation. You can use round brackets because we are not including -1 and 2. So you write on x is an element, open round brackets, -1, comma 2. That is interval notation. The second question, write down the x coordinate of the point of inflection of g. Now, if you start on the left-hand side, extreme left-hand side, x is less than -1, the function decreases. The function decreases to a stationary point which is a minimum. Then it increases. So from -1 up to 2, the function increases. Reaching the maximum there, and then it decreases. Okay, the point of inflection is between the -1 and 2. Let me illustrate this again. From -1, it increases, and then it decreases. So in between, so if you have an increase and a decrease, the description of the point of inflection is the midpoint from -1 to 2. And what is the midpoint there? It will be, you add the two numbers, 2 and -1, x coordinates, and divide by 2. So the x coordinate of the point of inflection is 1, somewhere there. Now, for which values of x will g be concave down? If you recall the parabola, I'm going to take a portion, let's say for x is greater than 0. I'm just taking a portion of the graph for x greater than 0. And if you just consider that part, it looks like a parabola, right? And that is concave up. So when you talk about concave up, we are looking at the maximum. So from the point of inflection, where x equal to 1, for x greater than half, you'll get it'll be concave, the graph will be concave down. And think of the parabola minus x squared, right? The arms point downwards. And further, the coefficient of x is -1. Now, question 8.4, given g prime x equal to -x squared plus 6x plus 12, determine the equation of g. Now, this is the derivative, so obviously the original equation would have been a cubic equation. Right. Now, the general form of the cubic equation is ax cubed plus bx squared plus cx. Plus d, well, obviously d is 0. Agree? Because it passes through the origin. Now, that is the equation of the cubic function. If I have time, I'll do another example with you. That's important. Now, you're given the derivative equal to, okay, let's find the derivative of ax cubed plus bx squared plus cx. The derivative is 3ax squared plus 2bx plus c. But you're given the derivative to be minus 6x squared plus 6x plus 12. So let us compare 1 and 2. Let's compare the coefficients. Now, what you have there is the x squareds, the x's, and the constant. Well, c and 12, so obviously 12 is a constant, and there's c. So c is equal to 12. Similarly, 3a is equal to minus 6, a is equal to minus 2, 2b is equal to 6, therefore b is equal to 3. So the required cubic function is minus 2x cubed plus 3x squared plus 12x, and remember the constant is 0, and we saw from the graph it passes through the origin. We need to look at the next question. Determine the equation of the tangent to G, to the curve, that has a maximum gradient. Right, we need to look at the graph again. Right, we want to find the equation of the tangent to the curve at a particular point, but this point has a maximum gradient. Now, where is that point? Oh, it happens to be the point of inflection, where x is half. Now, when x is half, we can find the y coordinate, because every point on the curve or on the Cartesian plane must have an x and y coordinate. So given x half, therefore the y coordinate right at the bottom is minus 2 times half times half times half plus 3 times half plus 12 times half. And you simplify that, you get 6.5. So at the point half and 6.5, you draw a tangent. Now, you need the gradient. Now, the gradient is obtained from the derivative. G prime x equal to minus 6x squared plus 6x plus 12. Now, when you substitute in this equation, you will get the gradient, the value for m. Please don't confuse substituting the original. When you substitute in the original equation, you will get the y coordinate. If you substitute x in the derivative, you will get the gradient of the line which is tangent to the curve. And the gradient there is, if you simplify that, you get 13.5. Now, what is the equation of the straight line? Y minus y1 is equal to m into x minus x1. We know the m value is 13.5, x1 is half, and y1 is 6.5. So you can complete that. It's quite easy. Now, that's the first part of the calculus. And usually, the last part will have a question on maxima and minima. Right. This is the problem solving. I just gave you discussed a few strategies last week on problem solving. Right here, you've got to draw a diagram which is not given. Let's spend a minute or so. We can read through this question. And we're looking at a closed rectangular box to be constructed as follows. Well, a box dimensions length, breadth, and height, or length, width, and height. So here you got length, width, height. We are talking about volume, and we're talking about cost. So there are a number of variables involved here. Also note that it's a closed box, as different from an open box. Okay, so let's look at this diagram here. Right, this is a closed box. There's a diagram. Well, if it's a closed box, it has a top and a bottom. This is the front, and there's the back of the box and on the sides. Now, this box is made up of six rectangles. The top and bottom are identical, the front and back, and the sides. Now we need to find, well, good, we have the length is 3x and the width is x. So the length is 3 times the width. So we'll put 3x and x. Now, the area of the top is 3x times x, area of a rectangle, but the bottom is the same. So you multiply that by 2, you get 6x squared. Now look at the sides. It's x times h, I'll call that h. And on this side is also x times h. So that's a 2xh. And the front is 3x times h. The back is 3x times h. So that will be 6x. Now the total, now we call it the total surface area. The total surface area will be adding these up, yeah, which is 6x squared plus 6xh plus 2xh. And if you want to be particular, it's in meters squared. Now, let's find the cost. The cost of the top and bottom is 15 Rand per square meter. So multiply that by 9. 15 times 690 squared. And the Other sides are 6 rand per square meter. 6 plus 2 is 8 times 6 is 48. So now you have a cost equation in terms of rands, which is 90x squared plus 48x, 48x h. Further, you're given that the volume is equal to 5 cubic meters. Now let's examine the cost equation. There you got two variables, x squared and the h. So we need to substitute for h so that the entire cost equation as one variable, single variable, which is x, which is in x. Now, the volume of a box is, well, all of you know, we all know, that is length times breadth times height, 3x times x times h, which is equal to 5, making h subject a formula, which is 5 over 3x squared. And now you can find the derivative. You're substituting the h there. To simplify this, c is equal to 90x squared plus 80 over x. Now, 80 over x can be written for convenience. Find derivative x to the minus 1. The derivative is 180x minus 80x to the minus 2 equal to 0. You simplify this and you solve for x, which is the width. I'll leave that as an exercise for you to complete. And your answer is 0.76. Okay, is that in order? Are there any questions? Oh, we put time. Okay, last week some of you asked a question about let's look at I'm going to this question, which is okay, there you are. The question was solve this, which Brandon did quite well. Solve it using logs. N to the power 200 is less than 5 to the power 300. Now, logs are very important. Logs are an extension of exponents or indices. When you're studying logs, it's dealing with the exponents, like the 200. N to the power 200 is less than 5 to the power 300. It's dealing with these exponents. Now, you find logs on both sides. If you got a is equal to b, then you can square. You can say a squared is equal to b squared. You can find the square roots. You can cube the both sides. So you can divide both sides by, you can divide both the exponents by 200, which is the easiest of the lot. And that will give you n to the power 200 divided by 200, 5 to the power 300 divided by 200, which will give you n is less than 5 to the power 3 over 2, and you can simplify that. There was a question by the student, so I just thought I'll quickly do this for you using logs. Right, take the logs on both sides. If you take the logs on both sides, then you'll get log of n to the power 200 is less than equal to, sorry, there's no equal sign there, is less than the log of 5 to the power 300. And taking logs on both sides. Then using the properties of log, you get 200 log n is less than 300 log 5. So you notice the law, log of a to the n is n log a. So you got 200 there and 300. Dividing both sides by 200, you get log of n equal to 3 over 2 to the log 5. And once again, the 3 over 2 log of a to the n is n log a. So that becomes 5 to the power 3 over 2, which is n is less than 5 to the power 3 over 2. Now 5 to the power 3 over 2, what is that? If, in the exponent, if your denominator is 2, then you're finding square root of 5 to the power 3, and the square root, you find the square root of 5 cubed. 5 cubed is 5 times 5 times 5, which is 125, the cube root of 125. Well, we know that 10 times 10 is 100, 11 times 11 is 121, so the closest value there is 11. So the answer there was 11. I think Brandon did it the other way. I just did this to answer the question posed by one or two students. That's your log question. Okay. Now there was another question. The question was using straight lines, how do you solve the inequality 1 minus x times, I think it's x plus 2, the x plus 2, less than 0. And to solve this, you just draw the two lines, y equal to x plus 2 and y equal to 1 minus x. And you can draw the graphs and work that out. Okay, what is missing here is this, that is the x-axis. And that's a graph. The graph cuts at 1. And that's here. Controlling this. Right. So it cuts at 1 and minus 2. Now, for x greater than 1, okay, there's your 1 there. Got it quite right here. This method, you don't have to use it. You can use a parabola. But what I want to point out is, for x greater than 1, this vertical line cuts the straight line at a y-coordinate which is positive and y-coordinate that is negative. So if you look at a times b less than 0, what does that mean? When you multiply two numbers, one must be positive and one must be negative. So the outcome is negative. So understand the question 1 minus x times x plus 2. These are two numbers. When you multiply them out, the outcome must be less than 0, and less than 0 means negative. So one has to be positive, one has to be negative. So if you draw this vertical line, x greater than 1, one is positive, one is negative. Therefore, x is greater than 1. And what happens in between, there, from there to there, you get x is positive, y is positive. So that will be, the product of that is greater than 0. Similarly, for x less than minus 2, if this is minus 2, you can see that somewhere there, that one is positive, one is negative. So that is a graphical way of solving the inequality. Okay, I will stop here and hand over to my colleague, Brandon. And students, I hope you do well in your exam tomorrow. Give it your best shot, and we hope for the best. Thank you very much for your participation.
Thank
Over
you.
to Brandon.
Thank you. If you do have any questions about this calculus section, please post all your questions in the chat, or you can send through an email to that link that has been posted. Okay, there's people there that can help you with those questions. Okay, so now we're going to go over the functions that we didn't complete last time, and then the new section on probability that was requested. Okay, just before we begin, I'd just like you to take note of session 3. That is going to be happening on Saturday, the 6th of November, from 9 to 12 again. Okay, so over there, we will be going through paper 2, okay, and then all those sections there. Okay. Okay, so let's get started with the function section. So this is question 5 from Maths paper 1, 2020. So we have an exponential graph here. F of x is equal to 3 to the minus x. Okay, so we know if the exponent is negative, we should expect a decreasing graph, which is what we get here. Okay, so let's look at question number 1. Write down the coordinates of A. So we see that A is along the y-axis. So if it's along the y-axis, we call it a y-intercept. So whenever we're dealing with the y-intercept, we need to let x be 0. Okay, so y-intercept, that means we let x be 0. So we just take our function f and we evaluate that at 0. In this case, it will be 3 to the minus 0, but anything to the power 0, that's just going to be 1. So that means we have a y value of 1. So we can write a as the x value that we set to 0 and the y value that we found to be 1. Okay, 5.2, determine the coordinates of B. Now with B, we don't know what the x part is. However, we see that it's on this common line here at y equals 9. So B will have a y value of 9, but we don't know what the x value is. However, we can work backwards to find the x value. So if we know that the function evaluated at some x part, at some x there, is equal to 9, we can work backwards to find what x is. So we're going to have 3 to the minus x is equal to 9. Okay, so we've got exponent work here, which means we need the same base. If we have the same base, then we can compare the exponents. In this case, the smaller base between the two is 3. So we should write both sides as base 3. So this will be 3 to the minus x is equal to 3 squared. Okay, so that's going to be 9. However, now that we know that the bases are the same, that means that the exponents must also be the same. So from this, we can conclude that minus x is equal to 2. So x is equal to minus 2. And we can do a quick little sanity check there. We see that B is on the left-hand side of the y-axis, which means x should be negative. And look at this, we do have a negative answer for x, so that makes sense there. Okay, if you do have any questions while I'm going through this, please just post them in the chat and we can get to those promptly. 5.3, write down the domain of F inverse. Okay, so now there's 2 ways to go about doing this. There's 2 ways to go about doing this. Either we can do the trick whereby if we know the domain and the range of the original function f, then they swap when we look at the inverse. So the domain becomes the range and the range becomes the domain. Or we can go about it doing the long way, whereby we find f inverse and then look at what the domain should be. Okay, so let's do this in two ways. Let's start off by finding F inverse and then seeing what we can do from there. Okay, so we know f of x is equal to 3 to the minus x. Okay, so we want to find F inverse so we can look at what the domain will be. So in this case, we need to swap x and y. So y is equal to 3 to the minus x. We are going to swap x and y and then solve for y. So x is equal to 3 to the minus y. We want to get rid of that. So we need to take the log on both sides. So log base 3 of x is equal to log base 3 to the minus y. Okay, so the log and the exponential, those are inverses, so they cancel each other out. So we left with log base 3 of x is equal to minus y log base 3 of 3. However, if you take log base 3 of 3, that's just going to become 1. So we have y is equal to log base 3 of x, and this is going to be our F inverse. So F inverse of x is equal to log base 3 of x, and from this we can conclude that the domain is given by all x values greater than 0. Okay, so that's the longer way of finding F inverse first and then finding the domain. Or we could do it by inspection looking at the graph. We see that all of the y values on F are greater than 0. So if we do the inverting, we see that all of the x values on F inverse are greater than 0. Okay, the domain and the range are going to swap. Okay, but either way, we get the same answer. Oh, sorry, I forgot the negative there. Thank you for pointing that out. Yeah, so there's a negative there. Okay, if you have any other questions, please post them in the chat. Okay, let's take a look at the next question. Describe the translation from f to h. Okay, so f, that's our old function. H, that's our new function. And this new function h is equal to 27 over 3 to the x. Okay, so let's go through this one. So we have h of x is equal to 27 over 3 to the x. Okay, so what we want to do is start with our new function and work backwards to see how did we get from the old function to the new function. Okay, so in this case, 27 we can write as 3 cubed. And 3 to the x in the denominator, we can replace with 3 to the minus x. Okay, that's starting to look like f. However, we just need to merge these two together, and we're going to get 3 to the minus x plus 3, like so. However, if we look back at what our original function was, f of x was 3 to the minus x, we see that this new function h is our old function f. However, it's been shifted to the left by 3 units. So h is f, but shifted 3 units to the left. Okay. Remember, when we add some value to x, we're going to the left. When we subtract some values from x, we're going to the right. In this case, it's plus 3. So that means we're going to the left. Okay, I hope that makes sense. If you have any queries, please let me know. Okay, 5.5. Determine the values of x for which h of x is less than 1. Okay, let's go through that one. So we know what h of x is. Now we want to know for which values of x is h of x less than, sorry, let's go back here, less than 1. Okay, so what is h? We've got a nice expression for that here. That's going to be 3 to the minus x plus 3. And this is to be less than 1. Now, remember what I said about exponents. Whenever we're dealing with exponents, we would like the bases to be the same so that we can compare the exponents. In this case, the bases are not the same. Okay, on the left-hand side, we have a base of 3. On the right-hand side, we have a base of 1. Okay, we can't do any comparison. However, we can rewrite this as 3 to the 0. That's just another way of writing 1. However, writing it like this ensures that the bases are the same. Okay, now we can compare the exponents. So in this case, we have minus x plus 3 is less than 0. Minus x is less than minus 3. So x is greater than 3. Okay, so these are the values of x, where h of x is less than 1. Okay. So that's it for this exponential question. Let's take a look at the next one. Okay, so this is question 4 from Maths Paper 1, 2019. Okay, in this case, we have a hyperbola G and a parabola F. Okay, we've got some questions to answer here. So firstly, 4.1, write down the value of P. So we see that P, if we look, that appears in our G expression. So G of X is equal to A over X plus P. Remember that value of P determines where the asymptote is. So we know that the asymptote is at X equals 1. We can see that on the right-hand side here. So if we know that the asymptote is 1, we can infer that the value of P needs to be minus 1. Why? Because the original asymptote was along the y-axis. However, it's been shifted to the right by 1 unit. And so in our function g, we also need to shift x to the right by 1 unit. So that means minus 1. Okay, 4.2. Show that A equals 3 and B equals 2. Okay, so we see over here, A appears in the expression for G, that's the numerator there, and B, that appears in our expression for F over there. Okay, so what can we do to try and solve this? Well, we know that F has a turning point at C and passes through the x-axis at 1, 0. So if it passes through that point, that means we can substitute that point into our function. So f of x is equal to x squared plus bx minus 3. We know that it passes through 1, 0, so we can substitute 1, 0. So in this case, the y value is going to be 0, and our x values are 1. So we have 1 squared plus b minus 3. Okay. So that means 0 is equal to b minus 2. So b is equal to 2, which is exactly what we wanted to show. As for a, what we need to do...
I think there's a problem. You forgot to sub with bx. You forgot to sub 1 with bx.
No, I did, but if we're multiplying by 1, you don't need to write that.
Oh, okay.
Sure, but thank you for the question.
Cool.
Okay. Next, we need to show that a is equal to 3. We've seen that a appears in the hyperbola g, so we need to find a point to substitute into the g expression. Okay, so what can we use? Well, we know that this hyperbola also passes through D, that point at the bottom. Now, D is the y-intercept of f, and we can write that down very quickly as 0 minus 3. Okay, so we have a point to substitute into G. So let's write down G. So G of x is equal to A over x minus 1. Yeah, and we need a point to substitute. We've got the point D, so let's substitute that. So we're going to substitute 0 minus 3. Okay, so that means the y value is minus 3, so that goes here. A, we don't know what that is. X is going to be 0 minus 1. Okay, so a little bit of rearranging. We can multiply both sides by minus 1. So we have A is equal to 3, and that's exactly what we wanted to show. So we've shown A and we've shown B. Okay, if you have any queries about the substitution, please let me know in the chat. Next question, 4.3. Calculate the coordinates of C. Now over here, if we just zoom in here, C, that is the turning point of the parabola, or it's the minimum of the parabola. Either way, however you want to interpret that. So to find the turning point, we need to take our parabola, x squared plus bx minus 3. And to find the turning point, we need to find the turning point form of the parabola. And to do that, we need to complete the square. So let's go ahead and do that. Yeah, so just make a little note. To find the turning point, okay, in our case, that's point C. We need to complete the square.
Sorry, can you use the the derivative to find the turning point?
Of course, yeah, you can do that as well. So we see that at the minimum, we know that the derivative will be 0, and you can also use that. That's perfectly fine. But if you get a bit stuck and you forget the derivative, you can also complete the square. Like I said last time, for many of these questions, there's more than one way to do things. And it's best to know multiple methods. So, if you get a bit anxious during the exam, it's good to know more than one method, because if you forget one, you have a backup. Okay, so in this case, you can use the derivative, or you can use the completing the square. Either way, it's perfect.
Okay, thanks.
No problem. Okay, so we need to complete the square. So we begin with our function f. So we have f of x is equal to x squared plus 2x minus 3, because we know the value of b now, so we can substitute. Okay, so how do we complete the square? So first step is to isolate your x terms. In this case, it's going to be x squared and 2x. We isolate them. Okay, that's step 1. Step 2, we need to take the 2x terms and put them into one bracket. So how do we do that? It's going to be x plus, because we've got a plus here, half of this coefficient. So this is our b coefficient. We divide it by 2. So it'll be plus 1 squared. Now, if we expand this out, we're going to get x squared plus 2x plus 1. Now, if we look at the previous line and this new line, you see we've got something extra. We've got an extra plus 1. So to compensate, we need to minus 1. And then don't forget the minus 3. Okay, so now we can remove those brackets. We don't need them anymore. So that's going to be x plus 1 squared minus 1 minus 3. That's going to be minus 4. And from this, we can read off the turning point. So here's one bit of information. Here's the other. So we can see that we have the parabola shifted to the left by 1. Okay, so if it shifted to the left by 1, that's going to be -1 for the x value. We also see that it shifted down by -4. Oh, that's -4. Okay, so that's the turning point. But remember, we labeled that C. So that's going to be C is -1, -4. Okay, and of course, you can use the derivative as well. Let's just go through that method. So we've got f. So f prime of x is going to be 2x plus 2. We want this to be 0 for the turning point. So x plus 1 is equal to 0. So x is equal to -1, exactly what we've got there. And to find the y value, we just look at f at -1. That's going to be -1 squared plus 2 times -1 minus 3. Yeah, and that's going to give us -4. Yeah, so we see we get exactly the same answer, 2 different ways. Okay, if you have any questions about these 2 ways, please let me know in the chat. Let's just put a little divide here so we don't mix them up. Okay, let's take a look at the next one. Okay, next, write down the range of f. Okay, that's pretty easy. We see that f is our parabola. We've already noted that it has a minimum, which means the range is going to be all of the y values bigger than this minimum. So it will be y is greater than or equal to -4. Remember, it is greater than or equal to, because we can include that bottom point. Sometimes we don't include the bottom point, but in this case we do. 4.5, determine the equation of the line through C. Okay, so we've got C over there. That makes an angle of 45 degrees, okay, with the positive x-axis. Write your answer in the form y equals, well, we know if it's a line, it will be y equals mx plus c. Okay, so let's go ahead and do this. Well, firstly, we know that it makes an angle of 45 degrees. So if theta is 45 degrees, that means the gradient will be the tangent of 45 degrees, but that's just going to be 1. Okay, so we've got m. Now, we know that it passes through the point C. Okay, and remember, C was given as -1, -4. Okay, we've got the gradient, we've got a point, we can find the equation. So y minus y1 is equal to mx minus x1. We know m, we know x1 and y1, we can solve. So y minus -4 is equal to 1, x minus -1. Okay, we've got a lot of double negatives going on here. So let's simplify. Y minus -4, that's going to be y plus 4. And this is going to be x plus 1. So y is equal to x plus 1 minus 4. So that's going to give us a -3. Okay, so that gives us our straight line with gradient 1 or angle 45. It means the same thing, and it passes through this point over here. Okay, as always, if you have any questions, please let me know in the chat. Next question, 4.6. Is the straight line determined in equation 4.5 tangent to f? So is a tangent? Explain your answer. Well, we've got this. We've got this line over here, y equals x minus 3. The question of is a tangent is the same question as does it touch the graph at one point? Okay, so it needs to touch at one point to be a tangent. However, in this case, we can see No, it does not touch at 1 point. So a little bit of substitution. We can see that y equals x minus 3, our straight line, passes through C. So it passes through C. We know that because that was given in the question. And this is the important part, and it passes through D. Why? Because take a look at this equation, y equals x minus 3. The y-intercept is at minus 3. Let's look at point D. D is 0 minus 3. So it passes through both of those points. And both of those points are on the parabola. So it is not tangent. It is not tangent. Because we know from the definition of tangent, it has to pass through 1 point. Here it passes through 2 points, and so it can never be a tangent. Okay, that's one way of answering. So let's just put a little 1 here. Another way of answering is to look at point C. Okay, as was mentioned before, we could also use derivatives to solve problems. In this case, if it was a tangent and it passed through C, then the gradient, let's just put this in red, should be 0. The gradient should be 0 for this tangent. However, we see that this gradient is in fact 1. So the gradients don't match. So it can't be tangents. So an alternate way is to say the gradients don't match at C, and so it can't be tangent. Oh, let's emphasize that. So it can't be tangent. Okay. So these are just 2 ways of explaining why it can't be tangent. Okay, I'm sure you can think of more. If you do have your own explanation, please post it in the chat, and then my colleague can look through that. Okay, but these are just 2 of the many ways that you can explain it. Okay, but if you're unsure, please let me know. Okay, last question here. The function h, okay, is equal to f of m minus x plus q. So we see that x has been shifted. So h is the original function, but we've shifted it around, and we've also shifted up by q. Okay. Has only 1 x-intercept. That's very important. Okay, it has 1 x-intercept. In other words, it was a parabola. However, we've shifted it around such that it no longer has 2 x-intercepts. It now only has 1, which means this parabola is just touching the x-axis, just touching at 1 point. Moreover, we know that this happens at x equals 0. Yeah, so it's at the origin. Determine the values of m and q. Okay, so what are these shifts? Okay, so let's start off with h and work out what those things should be. So 4.7. We know that h of x is equal to f of m minus x plus q. Okay, so what was f? We worked that out before. So what we need to do is take m minus x and substitute it into f. Okay, I'm going to use that turning point form that we derived. So it's going to be m minus x plus 1, all of that squared, plus q, but remember we also had that minus 4. from the turning point. Okay, so this inside part here shows us the shift in X. So this is the left and right shifting. This grouping over here deals with the vertical shifting, the up and down. Now we want the turning point to be at the origin. So we want the turning point to be at the origin. Okay, because remember, it said that the turning point was located at x equals 0. Well, that's the origin. So our shift in x must be 0. In other words, this m+1 shift must be 0. And the vertical shift must also be 0. We want no shifting. So it stays at the origin. So m is equal to -1 and q is equal to 4. These are our two values. Okay, so how did we answer this one? We wrote down h. We included the shifting from the question because there was some m shifting and q shifting going on. And we noted that if the parabola is at the origin, then the shifting must be 0. So that is this part and this part. And then from those two, we can find m and q. Okay. Okay, so that's it for this question. If you have any related questions, please just post them in the chat and my colleague will have a look at those. Next one, question 5. This is question 5 from 2019 Maths paper 1. So we've got ourselves an exponential. F of x is equal to k to the x, where k is greater than 0. Okay, that's good. The points 4 and 16 lies on f. Oh, that's over here. Okay, another thing to notice, here we go. The y-intercept is at 1. Okay, 5.1. Determine the value of k. Okay, so like before, we can work backwards. We know that there is a point that lies on the function, so we can work backwards to find what k should be. So we know 4, 16 lies on f. So we can take this point and substitute it into f. So that means 16 is equal to k to the 4. Okay, so how do we go about solving for k? Well, remember what I said before. Whenever we're dealing with things with exponentials, we want to have the same base. Now, on the right-hand side, we have a base of k. On the left-hand side, we have a base of 16. Okay, that's not going to work. So what we can do is reduce this base 16 to the smallest base that will help us. Okay, so in other words, what is the smallest factor of 16 that we can use as a base? Well, that's going to be 2. So in this case, we can write 16 as 2 to the 4 is equal to k to the 4. Oh, look at that. Now, we know that these two numbers are equal. And we know that these exponents are equal. So we can drop the exponents. So 2 is equal to k. Okay, we have our value. So that means f of x is equal to 2 to the x. Okay, because we know what k is. 5.2. Graph G, so that's our new graph, is obtained by reflecting the graph f about the line y equals x. Determine the equation of G. Okay. So 5.2. So we have our original function f is equal to 2 to the x, because we know what k is now. We can use that. We are reflecting about y equals x. So if we reflect about y equals x, then x becomes y and y becomes x. In other words, we swap x and y. Same procedure as finding the inverse, by the way. So we have y is equal to 2 to the x. So x is equal to 2 to the y. Okay, but we can't leave it as this. We need to solve for y. Okay, how do we do that? We take the logs on both sides. So log base 2 of x is equal to log base 2 of 2 to the y. Why did I choose log base 2? Well, because I've got a 2 over here. Okay, so we can do a bit of log working. So log base 2 of x is equal to y times log base 2 of 2. Okay, so now log base 2 of 2, that's just going to be 1. So we have y is equal to log base 2 of x. Okay, and they wanted it in the form y equals, so we can leave it like that. Okay. If you have any questions about this, please let me know in the chat. Okay, 5.3. Sketch the graph of G. Sorry, I see someone has a question. Please, if you don't mind, type your question out in the chat, and then my colleague can have a look. Okay, 5.3. Sketch the graph G. Indicate on your graph the coordinates of 2 points on G. Okay, that's easy enough. So we know, sorry, let's go back here. We know G is this new function we found. That is this y equals log base 2 of x. So we can do a little sketch of that. It's going to look something like this. Here's x, here's y, and we have y is equal to log base 2 of x. Okay, we also need to put 2 points on. Okay, we know this point over here is going to be 1, 0. Why? Because the original point was 0, 1, but remember we swapped x and y, so that's going to become 1, 0. And somewhere over here, doesn't matter too much. Previously, we had 4 and 16, so now we're going to have 16 and 4. Okay, again, we've just swapped x and y around. Okay, so this is our new graph, G. Okay, 5.4. Use your graph. Okay, so we've just drawn it, so we're going to use the graph now to determine the values of x for which f of x times g of x is positive. Okay, so where is f of x times g of x positive? Well, let's look back at f. We know that f is always positive. It never goes below the x-axis, so it's not negative. However, g is negative over here. It's negative in this region, and it's positive in this region afterwards. Okay, so this is the region we're interested in. Okay, because we want the product to be positive, f is always positive, so we just need to know where is g positive. And it's this right-hand portion over here. So that means x is greater than 1. Okay, if x is less than 1, it's going to be negative, so we don't include that. Next question. Again, use your graph to determine for which values of x is g of x less than or equal to -1. Okay, so we want to know where is g of x less than or equal to -1. Okay, let's just write out g because we know what that is. This is going to be log base 2 of x is less than or equal to -1. Okay, but we don't want to work with logs, so let's raise both sides using base 2. So 2 to the power log base 2 of x, that cancels out. That's less than or equal to 2 to the -1, but that's just going to be 1/2. So x is less than or equal to 1/2. However, very important note, it's not everything less than or equal to 1/2 because we've got this vertical asymptote at x equals 0. So we can't include anything before 0. So in fact, this is not our final answer. We need to include 0. So 0 is less than x is less than or equal to 1/2. Just remember here, there is a vertical asymptote at x equals 0. Okay, so we can't include anything before 0 because of this asymptote here. Okay, so remember to provide the full answer, not just the partial answer that I mentioned above. Okay, if you have any questions about this, please let me know in the chat. Okay, last question for this section here. If h of x is equal to f of minus x, so that is the reflection about the y-axis, okay, just to make note, calculate the value of x for which f of x minus h of x is 15/4. Okay, so let's work out what h of x is first before we look at the remaining calculations. So h of x was f of minus x. It was that reflection about the y-axis there. So this is going to now be 2 to the minus x. Okay, because remember f was originally 2 to the x, but now we're subbing in minus x, so it becomes 2 to the minus x. Cool, we've got h. Now, what did they want to know? They wanted to know f of x minus h of x is equal to 15/4. Okay, looks a bit strange, but let's see what we can do. F of x, so that's the unaltered form, was 2 to the x. H of x, that's going to be 2 to the minus x, and that's equal to 15/4. Okay, so this looks a bit complicated. However, let's rewrite 2 to the minus x with positive exponent. So it's going to be 2 to the x minus 1/2 to the x is equal to 15/4. Okay, now we know if we have something in the denominator, we can get rid of it by multiplying through by that value. Okay, so we want to get rid of that denominator, so we can multiply through by 2 to the x. And don't forget the right-hand side as well. So if I multiply through, that gets rid of that denominator. So this will be 2 to the 2x minus 1, because I clear the denominator, and this will be equal to 15/4, 2 to the x. Okay, looks a bit strange, but let's take everything over to one side and see what we can do further. So this will be 2 to the 2x minus 15/4, 2 to the x minus 1 is equal to 0. Okay, still looking a bit strange. However, we note that 2 to the 2x can be rearranged. So we can write this as 2 to the x squared, because we know if we take some exponential term and exponentiate it again, we multiply the exponents. So 2 to the x squared is just 2 to the 2x, which we had above. Okay, minus 15 over 4, 2 to the x minus 1 is equal to 0. Okay, so why did I do that? Well, now, if you just block out 2 to the x, this looks very quadratic. So let's just emphasize that by choosing another variable, let's say k. So letting k be equal to 2 to the x, we arrive at k squared minus 15 over 4k minus 1 is equal to 0. Now this is much clearer. This is just a quadratic. Yeah, we know how to handle quadratics. First of all, let's get rid of this 4 in the denominator by multiplying through by 4. Okay, I just want to get rid of the fraction there. So we're going to get 4k squared minus 15k minus 4 is equal to 0. Okay, that's a bit nicer than working with fractions. Okay, so this can be factored, okay, quite nicely into 4k plus 1 as our first factor and k minus 4 as our second factor. Okay, so I encourage you, just multiply that out if you have a piece of paper nearby and just convince yourself that that works. Okay, now that we've got two factors, we can solve each one separately. So this first one becomes 4k plus 1 is equal to 0. So 4k is equal to minus 1. K is equal to minus 1 over 4. But remember, what was k? Back over here, k is 2 to the x. Okay, so we've got 2 to the x is equal to minus 1 over 4. Oh, that's a big problem though, because 2 to the x is never negative. So it can never be equal to minus a quarter. So we immediately throw that away. That's not going to help us. Okay, invalid solution. You can also write NA not applicable. Okay, whatever you need to do, cross it out, write NA, write no solution, just write something to make it clear that you are not accepting that. Okay, on the other side, this looks a bit more promising. Or k minus 4 is equal to 0. So k is equal to 4. Okay, that's good. It's positive, which means we can actually solve this. So 2 to the x is equal to 4. Now, remember what I've been saying this whole time. Whenever you're working with exponentials, make sure you have the same base. Because if you have the same base, you can compare the exponents. Okay, so we've got base 2, base 4. 2 is the smaller base, so we should write everything as base 2. So this will be 2 to the x is equal to 2 squared. It's just another way of writing 4. However, now that we know both bases are 2, we can compare the exponents. So in this case, we just drop the 2's, so x will be 2. There we go. That's our only solution because we discarded the other one. This one, not a solution. This one is. So the only solution is x equals 2. Yeah, we threw away the other one. Okay, I hope that was helpful. If you do have any questions, please let me know in the chat. Okay, that was the last question here. Let's look at the next one. Okay, so that's it for the functions part. If we do have some time later on and you would like me to go through some more functions, please just mention that in the chat and then we can tally that up. Okay, so we might have some extra time later If you want some more functions questions, please let us know. Okay, but now we're going into the probability and counting. Okay, so this is question 10 from 2020 Maths paper 1. Okay, so question 10. In a certain country, 10-digit telephone numbers with the following format were introduced. Okay, so here's the format. We have 3 digits for the area code, 3 digits for exchange code, and 4 digits, that's just the number. Okay, so we see the first 3 out of the 10 is an area code, the next 3 is an exchange code, and then the next 4 is the number. Okay, if we add all of this up, we get back to the 10-digit telephone number. Okay, and there's an example mentioned there. Okay, oh, something very important here. Let's highlight that so we don't forget. Digits may be repeated. Okay, so if you use a 9 at the beginning, you can use a 9 later on. Okay, so we can repeat digits. 10.1, how many possible 10-digit telephone numbers could be formed? Okay, so let's look at that. 10.1. Now, the way that we should tackle these questions is by writing open slots for all of the possibilities. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 slots for the 10 digits. Now, we know that digits may be repeated. So how many digits are there? Well, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 digits can be used. So for the first digits, what can we use? We have 10 available. For the second digit, what can we use? We also have 10 available. For all of the digits, we have 10 available to us. So that's going to be 10 to the 10 possible telephone numbers. Okay. Sorry, that's looking like a 16. Sorry, that's a 10. Okay, 10.2. Certain restrictions were placed on the groups of digits. Okay, so let's highlight that. That's very important. Restrictions. Okay, so before there were no restrictions, but now that there are restrictions, there's going to be fewer numbers, right? Because we're limiting our choices. Okay, the area code. Okay, so for the area code, must be 3 digits, okay? And the first digit cannot be 0 or 1. So let's highlight that. It cannot be 0 or 1, which means we have the other available digits. Okay, so we're excluding those. Next, the exchange code must be 3 digits, okay? And the first and second digits cannot be 0 or 1. Again, okay. So it cannot be 0 or 1. Okay, so again, these are restrictions for us. And the last 4 digits, the number, okay, must be 4 digits. And the first digit must be 0 or 1. Okay, so we underline that as well. It must be that. So we only have 2 possibilities for the first digit of the number, because it must be 0 or 1. Okay, 10.2.1. How many valid 10-digit telephone numbers could be formed by applying the given restrictions? Okay, so let's go through that again. So it's still 10 digits. So we've got, let's write here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's break this up into area code, exchange code, and number. First 3, that's going to be area code. Next 3, that's going to be exchange code. Next 4, that's going to be the number. Okay, so let's just write that here. This is the area code. This is the exchange code. and this is the number. Okay, so for the area code, remember that the first digit cannot be 0 or 1. So if it can't be 0 or 1, we have removed 2 possibilities. So there are 8 possibilities left. The next 2 digits are unaffected. So we still have 10. We still have 10 for that. For the exchange code, it cannot be 0 or 1 for the first and the second digits. So for the first digit, we have 8 possibilities. For the second digit, we have 8 possibilities. Sorry, that's an all for 8. Let me do that again. And for the last one, it is unaffected. We still have 10. What about the number? The number must be 4 digits, and the first digit must be 0 or 1. So that means we have 2 possibilities. The remaining digits are unaffected. 10, 10, 10. Okay, so we've got all the possibilities. Let's just multiply them out. So we end up with 1,024 times 10 to the 9. Okay, so I've just written this in scientific notation. So we have 1,024 times 10 to the 9 possible telephone numbers. Okay. If you have any questions about this, please let me know in the chat and my colleague can help you out.
Why is it 1,024 times 10?
Oh, this is just scientific notation. So I've just multiplied everything out. So it's 8 times 10 times 10 times 8 times 8 times 10 times 2 times 10 times 10 times 10. Okay, so if you put all of this in your calculator, it will give you scientific notation here. Okay, it just saves you the trouble of writing out all of the zeros.
Okay, thanks.
Sure, no problem. 10.2.2, determine the probability. Okay, so let's highlight that. We don't want to make a mistake there. So we want a probability that a randomly chosen 10-digit telephone number would be a valid phone number. Okay, so basically what we're doing is we're looking at all of the possibilities. So these are all of them, all the possible numbers you could imagine. Now, how many of those are valid? Well, these ones are valid. Okay, so we've got all of them. We've got the valid ones, and we want to know the probability of picking a valid one. So what we want to do is take the valid ones, the number of valid ones, divided by all of them, and that will give you a probability. So the probability of, let's write this out full, of picking a valid number is equal to the number of valid ones, so the number that are valid. So this is the smaller set, right? It's the, with all the restrictions, that's the smaller one, divided by all possible numbers. Okay, so the number that are valid, that's the one that we just found, 1,024 times 10 to the 9, again, just in scientific notation there, divided by all the possible numbers, but that was the first one we found, that was 10 to the 10. Okay, now we can just do a bit of exponent cancelling, and this will be 0,1024. Okay, you see this is a very small probability. We see that this is a very small probability. Well, because this restriction was quite large. We put a big restriction on it, so the probability is going to be very small. Okay. If you do have any questions on this, please do let me know in the chat. And just a little side note, just talking about how we got this over here. Whenever you want to find probabilities of things, usually what we do is we look at what we want. This is just like a little mnemonic to help you out. What we want over all possibilities. And that will give you the probability of what we want. In this case, what we wanted was the number of valid numbers. So we put that at the top, and at the bottom, we put all the possible numbers because those were all the possibilities. Okay, so when in doubt, please just remember this little formula on the side here. Okay, and again, if you have any questions, please put them in the chat. My colleague is having a look at those. Okay, let's take a look at the next one. Okay, so this is question 11 from the 2020 Maths Paper 1. Okay, question 11. Harry shoots arrows at a target board. Okay. He has a 50% chance of hitting the bullseye on each shot. Okay, on each shot. So on the first shot, he has a 50% chance. On the second shot, he has a 50% chance. On the third shot, he has a 50% chance, and so on. Okay, so please keep that in mind. On each shot, 50%. 11.1. Calculate the probability that Harry will hit the bullseye in his first shot and his second shot. Okay, so probability is equal to, what's the probability that he hits the bullseye on his first shot? That's going to be 1/2. Now, in probability, whenever you see the word and, we translate that to multiply. So the first shot is 1/2 and the second shot is 1/2. So we're going to get 1/4. Okay, so that's the probability of getting a bullseye on his first shot and his second shot. 11.2. Calculate the probability that Harry will hit the bullseye at least twice in his first 3 shots. Okay, so there's a couple things we need to notice. At least twice. So that means a minimum of 2. So it could be 2 or it could be 3. Both of those are at least twice. Next, in his first 3 shots. So he's taking 3 shots, and we want to know what is the probability that he will hit the bullseye twice or 3 times. Okay, so remember what I said there, or. In probability, whenever you see the word or, we mean addition. So, 11.2. Let's take a look at this one. So, probability P is equal to, let's handle the first case. So if it's at least twice, it's going to be bullseye times bullseye times, no, it doesn't make it. Plus he can do bullseye, no, and bullseye. Sorry, just give me a second. Okay, sorry about that. Let's continue. So this is equal to, we already know what the probabilities are. Oh, sorry, missing a few here. Plus, he doesn't make it on the first. He makes it on the second, makes it on the third. plus, remember what I said with at least, he could do it all 3 times. So bullseye, 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 because that's still at least 2. So let's put some values to these letters. So we know that it's 50-50, right? So for this first one, it's going to be half times a half times a half, plus half times a half times a half, plus a half times a half times a half, and the last one, 1/2 times 1/2 times 1/2. Okay, now we know that the probability of a bullseye and the probability of not a bullseye is 1/2 and 1/2, but please don't get mixed up with that. If the probability of a bullseye was less than 1/2, then the probability of not a bullseye would be 1 minus that. Okay, so the only reason we have halves all over is because they have the same probability. Okay, that's not always the case. They could be different. So what do we have here? Half times a half times a half. Well, that's 1/8. How many of those do we have? We have 1, 2, 3, 4 of them. So 1/8 times 4, it's going to be 1/2. Okay, so he's got a 50% shot at doing that. Okay, I hope that makes sense. If you have any queries, please let me know in the chat. Okay, 11.3. Okay, Glenda, so that's a different person now, also has a 50% chance of hitting the bullseye. So let's underline that. That's important to know. So new person, Glenda. New person, Glenda here. Please just give me a second. Okay, so Glenda also has a 50% chance of hitting the bullseye on each shot. That's the same as Harry. Harry and Glenda will take turns to shoot an arrow. Okay, so let's say Harry goes first, then Glenda goes, then Harry goes, then Glenda goes. They alternate. We'll take turns to shoot an arrow, and the first person to hit the bullseye will be the winner. Okay. Calculate the probability that the person who shoots the first will be the winner. Okay, so how do we go about doing that? Let's just do that under the side here. So this is 11.3. We want to know that the first player, calculate the probability that the person who shoots first, so first up in the line, will be the winner. Okay, so first player's probability. Okay, so how does that work? Well, if they're going first, that means they have a probability of 1/2. Again, 50-50 shots. Plus, if they're going again, that's going to be the third time that they play, right? Because they do the first one, then the next person does the second, then that original person will do the third. We're going to have 1/2 cubed. Plus, then the next person will go, then it's back to this person. That will be 1/2 to the 5th. Plus, dot, 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 and so on. And this will continue, go on until one of them eventually wins. Now, this is a geometric series, okay, because we've got the same base raised to different exponents. We can sum this up. So this is given by A over 1 minus R. Okay, A is the first term, so that's going to be 1/2 over 1 minus, squeeze that in, 0.25. Yeah, simplifying this will give us 2/3. Okay, so we just sum up all of those using a geometric series. We're going to get 2/3. Okay, so that's summing up using a geometric series. However, we could also express this problem. We could also express this problem in a tree diagram. Okay, so how do we express this in a tree diagram? Well, each step in the tree we can consider as one of the players making a shot. So in the first case, what do we have? They can either hit the target, so that's a bullseye, with the probability of 1/2, or they could miss, so not a bullseye, and that will be also probability 1/2. So that's the first shot being made. Now, if they hit it as a bullseye, they've already won. Okay, so we can take that. Now, next shot that can be made. It's the same thing. So we can have a bullseye with 1/2 and not a bullseye with 1/2. Okay, same thing for this other part here. We can have a bullseye with 1/2 and we can have not a bullseye with also 1/2. Okay, then that's the third one. We can do this once more. It's getting a bit squashed here. At the top, we can have a bullseye with 1/2, not a bullseye with 1/2. Same probabilities throughout there. And again, we can branch this off here. We can have bullseye with 1/2, not a bullseye with 1/2. And the same thing for the next two. We can have bullseye with 1/2, not a bullseye with 1/2. Last one. Again, bullseye with 1/2, not a bullseye, again, 1/2. Now, what do all of these represent? So we start at the beginning and we walk down this tree structure here and look at the letters. So if we look at the top, the topmost path, we have bullseye, bullseye, bullseye. So that's bullseye, 3 in a row. The next one will be 2 bullseye and not a bullseye. Okay, so we have 2 bullseye and not a bullseye. Okay, and then the pattern continues. You just look at the branches and you can fill this in. So the next one will be B and B, B and N. Then we have NBB, NBN, NNB, and NNN. Okay, so we can see that these are our outcomes, all the possible outcomes. Okay, so here we see that we have a probability of 1/8 or 0.125 probability for each triple. And by triple, I mean this outcome over here. Okay, and then from this, you can see all the possible outcomes. Okay, if you have any questions, please just let me know in the chat and my colleague can have a look at that. Okay, let's have a look at this next one. Okay, so this next one is question 10 from 2019 Maths paper 1. So question 10, the school library is open from Monday to Thursday. Okay, so it opens on Monday up until Thursday. Okay, so not Friday, not the weekends. Anna and Ben both study in the school library one day this week. Okay, so one day out of the week, Anna goes to the library, maybe another day in the week, Ben goes to the library. Okay, so now we carry on reading. If the chance of studying any day in the week is equally likely, That's very important. Let's highlight that. If the chance of studying any day is equally likely. So Monday, Tuesday, Wednesday, Thursday, they all have the same probability. So let's make a little note there. So we have 4 days. They are all equally likely. So the probability for any given day is 1/4. Okay, because we've got those 4 days. Calculate the probability that Anna and Ben studied on, let's do this first one, the same day. Okay, so that means both of them on the Monday or both of them on the Tuesday, and so on. Okay, so 10.1. So we want to know the probability P that Anna, let's just write A, and Ben, B, studied on the same day. Okay, so that means both of them on a Monday or both of them on a Tuesday. Okay, and so on. Okay, so let's just write that out. We've got 1, 2, 3, 4 possibilities. Monday, Tuesday, Wednesday, Thursday. Okay, so on either day, their respective probabilities is 1/4. So that means the probability of any of these 4 days will be 1/4 for Anna, 1/4 for Ben, and it can happen on any of the 4 days, so times by 4. Okay, so this is going to be 1/16 times 4. So that's going to be 4/16. We could reduce that to 1/4. Okay, so that's the probability that they both studied on the same day, whichever day that it may be. Okay, if you have any questions, please let me know in the chat. Okay, 10.2, on consecutive days. So that means something like Anna studying on Monday, Ben studying on the Tuesday, because those are consecutive. Or Anna studying on the Tuesday and Ben studying on the Wednesday. Again, those would be consecutive as well. So what are the possibilities for consecutive days? So 10.2, let's make a little note here, consecutive days. So I pointed out some of the options. The first one would be something like Monday, Tuesday. Those are consecutive days. The next 2 consecutive days would be Tuesday, Wednesday. And the last consecutive pair of days would be Wednesday, Thursday. Okay, so these are our options. We can have the first option, Monday, Tuesday. The second option, Tuesday, Wednesday. The third option, Wednesday, Thursday. Okay, so what is the probability of being in consecutive days? So the probability P is going to be, well, we have 3 options available there, and then that's going to be times 2/16. That will be 6/16. Okay, so how did we get this? Well, we can look at the first part. So 1/4 times 1/4. This is going to be the first one. Let's say A is studying on that day. The next one, B studying. Okay. Then we need to multiply this by 3 because there are 3 possible consecutive day groupings. The Monday, Tuesday, that's one grouping. Tuesday, Wednesday, that's another grouping. Wednesday, Thursday, that's another grouping. However, we need to multiply this by 2 because of the symmetry of the problem. So let's just write here symmetry, because we don't know who is studying on which day. Maybe Ben is studying on the Monday, Anna is studying on the Tuesday, or Anna is studying on the Monday, Ben is studying on the Tuesday. Each of those give an extra possibility. So we need to multiply by 2. So we can either read this as A or B is first. And like I said, whenever you see or, it means you add them. Okay, and that's how we get our results. Okay, are there any questions so far about this? The question here, how is it 2 over 16? The 2 comes from this symmetry here. So we don't know who is first. So let's take this example of Monday, Tuesday. We can either have Monday being Anna, and Tuesday being Ben. So that's one possibility. Or we could have Monday being Ben and Tuesday being Anne. So you see we get 2 possibilities for each one. Okay, so whatever we get, we need to multiply by 2 for the 2 possibilities. Okay, and that's because we've got this or over here. Sure, no problem. Okay, are there any other questions? Okay, I don't see any questions here. So we're just going to stop for 5 minutes just to give you some time, give you a little break. And if any of you have questions related to what we've been doing so far, or maybe some other questions, now is the time to post all your questions in the chat. Okay, also, if you have any other requests, please put that in the chat as well. Okay, so we're going to take a quick 5-minute break for you to go through that. Okay, so I'll see all of you at 11:05.
Can we do function when we come back?
Yeah, sure, of course. We can go over some more functions. Okay, like I said, if you have any other requests, please put that in the chats as well. Okay, so we've got 1 request for functions so far.
Sam,
Hi, yeah.
can you possibly do those questions along with functions that deal with the roots, like that ask determine f of x is equals to k, where you have 2 positive real roots, stuff like that?
Sure, we can do that as well.
Yeah, please explain those things.
Sure, no problem.
Okay, thanks.
So can we also do financial maths where they ask us to find the balance of the loan, I think.
Okay. I don't know if we're going to have enough time for that. We'll see how much we get through. But if you do have specific questions from like past papers, please send that through to that email address. Okay, my colleague will post the email again. Okay, so if we don't get through that today, please send that through and we will help you personally.
Okay, thank you.
There's the email posted on the chat.
Sir?
Yes, hi.
One last question. Could you show us at the end of the lesson how to get to the recordings on that website that you guys sent us?
Oh, of course, yeah. We'll go through that as well.
Thank you, sir.
Sure, no problem. Hi, yeah, I'm still here. We will be back at 11:05. Okay, we're just taking a break so that you can post your questions and requests for the next part of the session. Okay, so if you have any issues, please just post them in the chat and we can take a look. Okay, I've got a question here. You've got a question in your textbook. Okay, if you can't share the question on Zoom now, please can you share it through the email? Okay, so the email address has been posted. Just take a picture and send it through to the email, and then someone will help you out with that. Hi, everyone. Welcome back from the break. We've taken a look at all of your requests that have been posted. We're dealing with that now. We just have to go through one more question on probability here. Then we'll do some more probability because that was requested. Then we will go through that extra functions that was requested. Okay, so all of your requests have been taken into account. Just before we begin with the extra probability, someone asks here, will trig graphs be done? That will be in the next session. Okay, so trig graphs will be done in the next session. Okay. Okay, so we're going to start again with the remaining probability. If you have any further requests, please put them in the Zoom chat. My colleague is taking a look at those. Just, you know, we don't have a lot of time to go through all of the requests. So if we don't get through to your part, please just post your questions to that email. Okay, and then we can help you out one-on-one with that. Okay, so I'm really sorry if we can't get through to everything, but if you email us, we will get back to you within a day. Okay, maybe even half a day. Yes, someone made a good point there. Functions do count more than finance, so we will be doing the functions part. And then if you do have any finance questions, please send it through via email. Okay, so let's carry on with the probability. Okay, so this probability question is question 11 from 2019 Maths Paper 1. Okay, question 11.1. Events A and B are independent. Okay, that's good to know. Now, we know that they're independent. Now we need to know, what does independent mean in terms of probability? Next, The probability of A is 0.4. The probability of B is 0.25. Okay, so let's just make a little note here. 11.1.1, independence events. Okay, so what does it mean for two events to be independent? We have that the probability of A and B is equal to the probability of A times the probability of B. So this and that appears between the A and the B, it becomes multiplying on the right-hand side. So this is what it means for two events to be independent. Now, we know the probability of A, we know the probability of B. That's 0.4 for A, 0.25 for B. So that gives us 0.1. Okay, so that's just a little side note on independent events. Okay, so let's go through the question. Represent the given information on a Venn diagram. Okay, so that's the one with the overlapping circles. Indicates on the Venn diagram the probabilities associated with each region. So we're going to have 3 regions. We want to work out what is in each region. So we start off with the sample space. That's all the possibilities. We have circle A. We have circle B. Now, what do these regions represent? We have the region with just A. We have the region with A and B. We have the region with just B. And of course, we have the outside region, which is the rest of the sample space. Okay, so what is the probability of just A? So that's this part over here with no B overlapping there. So this is going to be 0.4 minus 0.1. Why 0.1? Because that's the intersection part. And that's going to be equal to 0.3. So we can just erase this and we can put 0.3. Inside the overlapping part, we know that's 0.1. What about just B? So the probability of just B, well, that's going to be the probability of B altogether. That was 0.25 minus the intersection there, 0.1, and that's going to be 0.15. Okay, so that goes in this region over here. Okay, so now we need to check the sample space though, because we've got 0.3, 0.1, 0.15. However, that doesn't make up the full probability. We're a bit short. So how much is actually outside in the rest of the sample space? So that will be 1 minus 0.3 minus 0.1 minus 0.15. It's everything else not included in the circles. And that will be 0.45. We need to add that outside here so that the sum is equal to 1. Please do not forget to include this extra term on the outside. Okay, everything has to add up to 1. Okay, let's take a look at the next one here. 11.1.2, determine the probability of A or not B. Okay, so that's a bit wordy, so let's rewrite that in terms of what we know. Okay, so this, we want to find the probability of A or not B. Okay, so what does that actually mean? Let's break this up nicely. Remember, when you see an or, that means we split it into 2 parts with a plus. Or means plus. So that will be the probability of A plus, because we've used or, the probability of not B. Okay, good. Now, okay, we're not done yet. We need to subtract the probability of A and not B. Okay, because of that overcounting there. Okay, so the probability of A or not B is the probability of A plus the probability of not B minus the intersection. Remember, that is how we split up ORs. So this is going to be equal to 0.4 for that one plus 0.75. Why 0.75? Because it's 1 minus the probability of B. Minus, what's the probability of A and not B? That's 0.3. Okay, adding all of this up, we get 0.85. Okay. So this is a method whereby we split the probability into simpler probabilities. However, we could do this another way. So let's just put here, or an alternate method is the probability of A or not B, same as what we had before, is equal to 1 minus the probability of just B. Okay, that's the part of the Venn diagram with no other intersections there. Okay, so this is going to be 1 minus 0.15, and we get 0.85. Sorry, let's rewrite that, 0.85. Same probability, a whole lot easier. Okay, but it's the same idea in both cases. There is another way that we can do this, or we could look at the Venn diagram. So we could look for this region over here in the Venn diagram. Okay, and just add up the values for the regions there. However, this method is not recommended though. Okay, the reason I say it's not recommended is because if you make a mistake in your Venn diagram, then this will be wrong as well. Okay, so just keep that in mind. Okay, if you got a mistake in your Venn diagram and you use the Venn diagram for other questions, those will also be marked wrong. Okay, so just be careful of that. Okay, and as always, if you have any questions, please post them on the chat. My colleague and I will have a look at that. Okay. Last bit of probability here, 11.2. Motors Incorporated manufacture cars with 5 different body styles. Okay, that's important. 5 different body styles. So you can choose out of those 5. 4 different interior colors. Okay, so we have choice of that. And 6 different exterior colors. We can choose that. Okay, so let's just go over this again. What can we choose? We can choose 1 out of the 5 body styles, 1 out of the 4 interior colors, 1 out of the 6 exterior colors, and that gives us our car. Okay, however, there are some restrictions. Number 1, the interior color of the car must not be the same as the exterior color. Must not be the same. So once we've chosen one of the colors, we cannot repeat the color for the other option. Sorry, I've got a question here. Why did you put 0.3 for probability of A and not B? Let's just go to that part over there. 0.3 That's this 0.3 over here. That region over there. Okay, that's 0.3. That's A and not B because we have excluded the intersection there. Okay, I hope that makes sense. Okay, let's go back to this. Okay, so like I said here, once you've chosen the one color, you cannot choose it again for the next color. Okay, Motors Incorporated want to display one of each possible variation of its car. Okay, so let's highlight that, the possible variations. So that's all of the possibilities that you can choose from, provided you stick to that restriction. Okay, the showroom has a floor space of 500 meters squared. Okay, so that's the total space. And each car requires a floor space of 5 meters squared. Is this display possible? So what do they want? They're asking, if we look at all of the possible cars that satisfy the restriction, of course, if we look at the total area covered by all of those cars, would that fit in the showroom space or not? Yeah, that's what we want to know. So how do we answer that question? We need to know how many cars are there. Okay, so let's take a look at this one. Okay, so, oops, sorry, let's look at the interior. That is one of the options. Exterior. That was the other option to choose from, and body style. Okay, so for the interior, we had blue, gray, black, and red. So those were the options. What about the exterior? Okay, we have 5, 5, 5, and 5 possibilities to choose from. What about the body style? It's going to be 5, 6, 6, and 5. Okay, so those are the options that we can choose from. Okay, so we want to look at the number of combinations. So the number of combinations will give us the number of cars that we have available. So this is going to be equal to, well, it's going to be 1 if we pick. Okay, so 1, that's our first pick, times 5 times 5. That's our first pick there. Plus, we're going to have 1 times 5 times 6. That's our second pick over there. Plus 1 times 5 times 6. That's our third pick if we're going down the list. Plus, and then the last one will be 1 times 5 times 5. That's our last pick. Okay, so we can just see if we look down our table, blue, gray, black, red, those are our picks. We have the same thing going down here. Okay, we just multiply this out, add it together, and we get our result. So the first one's going to be 25 plus 30 plus 30 plus 25. Okay, adding these up, we're going to get 110. 110 what? Well, we have 110 cars. Okay, so now this isn't the end of the question. This is just how many cars are available. So each car takes up 5 meters of showroom, 5 meters squared of showroom floor. So we have 110 cars times 5 meters squared per car. So that's going to be 550 meters squared. Now remember, the showroom only had 500 meters squared. This is greater than 500 meters squared. And that's a big problem because the total area of the cars is bigger than the showroom has available. So that means this display is not possible. Okay. Okay, are there any questions about this? Okay, no questions. If you do have any questions later on, please just forward that through to the email and then we can answer you there. Okay, I think we have time for one more probability question, and then I'll owe you some functions questions. Plotting Venn diagram. Okay, sure. That's going to be the next question here. Okay, so let's take a look at that. Okay, so we're going to look at some more on probability. Okay, and specifically Venn diagrams, because that comes up a lot. Okay, so let's see what we've got. Okay, so we've got here question 10. Okay, and this is from the 2017 paper. Okay, so this is question 10. Okay, so I've got the question here. A survey was conducted among 100 grade 12 learners. Okay, so we have 100 grade 12 learners. Okay, the survey was about their use of Instagram, Twitter, and WhatsApp. Okay, so we have Instagram use. Let's just call that I, so we don't have to write Instagram all the time. Twitter, call that T, and WhatsApp. Let's call that W. Okay, so those are just the code words there. Okay, and we have the results from the survey. Okay, so the results are that 8 use all 3, 12 use Instagram and Twitter, 5 use Twitter and WhatsApp, but not Instagram. Okay, we've got X, so we don't know what X is. Use Instagram and WhatsApp, but not Twitter. 61 use Instagram. Just a little note here. When you read that 61 use Instagram, that is not saying that they only use Instagram. That could just be one of the things that they use. Okay, so when they say 61 use Instagram, it's not only Instagram, it could be others included as well. Okay, so please remember that. Okay, 19 use Twitter. And 73 use WhatsApp. Okay, and again, the 73 is not WhatsApp only, it's WhatsApp and it can include other things as well. Okay, and 14 use none. So that means they're outside of our Venn diagram. Okay, so these are the results. What we want to do is illustrate this information in a Venn diagram. Okay, so we've got 3 things. which means we're going to have a triple overlap going on. So let's just draw our total space here. And we've got 3 overlapping circles. Okay, like so. Let's label the top one R for Instagram, this one W for WhatsApp, and this one T for Twitter. Okay, so we have X, over here, 8 use all 3. So that means they're right in the middle, they're using all of them. Okay. Now, X use Instagram and WhatsApp, but not Twitter. So Instagram and WhatsApp, not Twitter, that's going to be in this portion over here. Okay. 5 use Twitter and WhatsApp, but not Instagram. That's going to be over here. And then we're going to have Instagram and Twitter. Okay, we're going to have 4 over there. Okay, and then what's remaining for Twitter? Okay, so we've got 5, 8, 4. So currently the remaining is going to be 2. Okay, if you just add that up there. Okay, so that 2 means Twitter only. Okay, what about Instagram? We've got X, 8, and 4. We know the total Instagram users, so the leftover is going to be 49 minus X. Okay, that's the leftover part there. What about WhatsApp? We know that the total is 73. Currently, we have X, 8, and 5. So that means the remainder is 60 minus X. Okay. And what about those that don't use any of them? That was highlighted here as 14. So there's 14 outside, which means they don't use any. Okay. Next question, 10.2. Calculate the value of X. Okay, so how do we go about doing that? Well, we know what the total is, and X is just missing from that total, so we can work it out. So we're going to have 49 minus X. That's our top value over there by the R, plus X plus 8 plus 4 plus 60 minus X. We've got that for WhatsApp. Missing plus 5 plus 2 plus 14 on the outside there. And this all needs to be added up to 100 because we've got 100 learners. Okay, so adding all of this up, we end up with minus X plus 142. So that's adding up all the numbers is equal to 100. So we see that X must be 42. So remember, X was in this portion over here.
Can I ask?
Yes.
Why is it 60 minus X?
60 minus X. Let's just check that here. Oh, that was this under here with WhatsApp. So we take the total for WhatsApp, that was 73, and we take away what we currently have. So there's X, 8, and 5. We take those away. And that gives you the leftover.
Oh, okay.
Yeah. Okay, and then 10.3, last one here. Calculate the probability that a learner chosen randomly, so we pick one of the learners out, uses only one of these. Okay, so let's take a look at that one. So we want to know the probability of only one. Okay, so remember that formula that I said before. It's what we want divided by the total. And that will give us the probability of what we want. So the probability of only one. So that means only WhatsApp, or only Instagram, or only Twitter. Now I've used a bunch of ors there, so that means addition. So we're going to have 18 for WhatsApp only, plus 2 for Twitter only, plus 7 for Instagram only. Divided by the total, well, that's just all of the learners, that's 100. And that's going to be equal to 27 over 100. And we can write that as 0.27. Okay, so this is only one. So in this case, only Instagram, or only Twitter, or only WhatsApp. Okay, are there any questions about this? Let's just go through here. Okay, let's just see. Okay, no questions. Awesome. Okay, so let's go back to the functions questions. And then we might have some time for finance, but I don't think so. Okay, but if you do have any finance questions, please post them on the email and we will get to them promptly. Okay, let's go back to functions. Okay, so we're looking at question 4 from November 2017. Okay, so if you want to go back and look at this paper, it's question 4, November 2017. So we're given this function f. So f of x is equal to minus ax squared plus bx plus 6. Okay, so 4.1. Okay, we are given that the gradient of the tangent to f, okay, so the gradient of the tangent to f, okay, so we've got the gradient of the tangent to f at the point minus 1, comma 7 over 2 is 3. Okay, so the gradient to f at this point is 3. We need to show that a is equal to 1/2 and b is equal to 2. And b is equal to 2. Okay, so let's go through this one. So how do we find the gradient of the tangent? So we take the derivative.
Derive.
Yes, that's right. So let's write down f again. Sorry, I made a mistake here. This is not 2017. Sorry, this is... Okay, this is sorry, no, it is November 2017. Okay, so we want to show that a is equal to 1/2 and b is equal to 2. So we derive what we're given. So f of x is given as minus ax squared plus bx plus 6. We can take the derivative. So f prime of x is equal to minus 2ax plus b. Okay, but we know that the gradient of this tangent at that point is 3. Okay, so that means f prime of x is equal to 3. Okay, but we know that this happens at x is equal to minus 1. So we can substitute that in here. So this is going to be minus 2a. We sub in x is minus 1 plus b is equal to 3. So this is going to be 2a plus b is equal to 3. Okay, so this is one equation that we can use to solve for a and b. Now we need another equation. Well, we know that f passes through this point. Okay, because if that's the tangent point, it's also a point on the curve. So we can take this point and substitute it into our equation, and we get an equation 2. So f of x is equal to minus ax squared plus bx plus 6, and we can substitute the tangent point. That's going to be minus 1 and 7/2. Okay, so that means the y value is 7/2, and the x value is minus 1. So we have minus a minus 1 squared plus b times minus 1 plus 6. Okay, so we have 7/2 is equal to minus a minus b plus 6. Okay, and we can use this as our equation 2. So we've got equation 1 in terms of a and b. We've got equation 2 in terms of a and b. That means we can use simultaneous equation to solve this. So we can solve this simultaneously. Okay, so let's just rewrite what we've got. We've got 2a plus b is equal to 3. This was our equation 1. And we've got minus a minus b plus 6 is equal to 7/2. This was our equation 2. Okay, so we need to substitute one into the other, and then we can solve. Okay, so let's take equation 2 and solve for a. So we're going to have a is equal to b minus 6 plus 7/2. Okay, we're going to take this and sub it into equation 1. Okay, so we've got our value for a. We can use that in equation 1. So this is going to be 2 times b minus 6 plus 7/2. That's our value of a, plus b is equal to 3. So this gives us 2b minus 12 plus 7 plus b is equal to 3. So we're going to have 3 times b is equal to 3 plus 12 minus 7. Okay, and then we can solve for b, just adding those together, dividing by 3. We end up with b is equal to 2. Okay, now that we've got b, we can also solve for a. So we know that 2a plus b is equal to 3 from equation 1. We've got our value for b. So 2a plus 2 is equal to 3. 2a is equal to 1 So a is equal to 1/2. Yeah, as we wanted. Okay, are there any issues with this question?
So please repeat.
Okay, the whole question or just this last part?
From where you start deriving.
Okay. Okay, let's go through this again. So we've got our function f. Okay, that's this parabola over here. Okay, we know that the gradient, so that means f prime, that's what gradient is. F prime of x at this point is 3. So that's what we're doing over here. We take f prime. Okay, we do the derivative there. We get minus 2ax plus b is equal to 3, because that's what we said the gradient was. Okay, but it was at this point. So x must be minus 1. So we can substitute minus 1 and we get equation 1. Okay, but we've got 2 unknowns. We've got a and b. Those are unknowns. So we need another equation. So what we can do is take our function and substitute the tangent points. Sub in the tangent points. Okay, if we substitute the tangent points, we get another equation in terms of a and b. We can call that equation 2. So we've got 2 equations, 2 unknowns. We can solve simultaneously. So I just solved for a, substituted it into the other equation. I got b. Then once I've got b, I can find a. Okay, I hope that makes sense. If you have any other queries,
Okay, thank you, sir.
please just let my colleague know. We can go through it. Okay, let's take a look at this next question here on the nature of roots. Someone asked for that. Okay, so we're still dealing with the function section. Okay, but we're looking at the nature of roots. Okay, so let's say we have some quadratic f that's going to be ax squared plus bx plus c. Okay, and we want to know what are the nature of roots for this. So in this case, we can use the discriminant. Okay, remember what the discriminant was. That was this triangle we call delta, and this is going to be b squared minus 4ac. Okay, that's the discriminant. Now, from the discriminant, we can look at what the nature of the roots are. So, firstly, if this discriminant is greater than 0, then we end up having 2 real roots. Okay. Number 2, if the discriminant is equal to 0, then we only have 1 real root. Okay, so you're going to get 2 solutions, but they're going to be the same. So we say 1 real root. Okay, or a repeated root. Number 3, if the discriminant is less than 0, then we have no real roots. In other words, the parabola is not cutting through the x-axis. Okay, we have no real roots there. Okay, so let's take a look at an example with this. Okay, so let's come up with some function. F of x is equal to f of x is equal to 2x squared minus 3x minus 4. Okay, and then this is equal to k for some constant k. So we want to know for what values of k will this expression have real roots. Okay, we want real roots from this. So we can rearrange this to be 2x squared minus 3x minus 4 minus k equals 0. Okay, so we can identify our factors here. This first one here, that's going to be A, that's going to be B, and these two combined are going to be C. So we have A, B, and C. Okay, so what we want to do now is calculate this discriminant from what we've got here. So we've got the discriminant, the triangle, is equal to B squared minus 4AC. So B is minus 3. So we're going to have minus 3 squared minus 4AC. Okay, so let's simplify this. So minus 3 squared, that's going to be 9. This is going to be minus 4 times 2 times minus 4 again. So that's going to be plus 32 and then plus 4k. Okay, so 32 plus 9, that's going to give us 41 plus 4k. Okay, so we've got our discriminant as simple as we're going to get it. So what did we want? We want to know where will this have 2 real roots. So for what values of k will the expression, the one we started off with at the top there, will the expression have 2 real roots? Okay, so what is the condition for 2 real roots? Let's go back here. 2 real roots, that happens when the discriminant is greater than 0. Okay, so we want the discriminant to be greater than 0. So what does that mean? It means that 41 plus 4k must also be greater than 0. Okay, so we have 4k is greater than minus 41. So k must be greater than minus 41 over 4. Okay, so this is the condition for 2 real roots. And you can do a very similar thing for 1 real root, then it would be equal to 0. And if you want no real roots, it must be less than 0. Okay, I hope that helps. Okay, let's just look through the chat here, see if there's any questions. Okay, nothing there. Okay, let's move on. Okay, so we've got a couple more function questions to go over. And then if you do have any finance questions, please post it to that email. Okay, so we've got another question here. This is question 4. Okay, so we've got a function f. So f of x is equal to ax squared. Okay, and we have that the domain for this function is x is less than or equal to 0. Okay, so it's everything on the left-hand side. Got a question here about the session. It will end at 12. but I just want to go through this last question. Okay, so f of x is equal to ax squared. Okay, and we also want to consider f inverse of x. Okay, so we've got f and f inverse, where p, okay, so we've got a point p is given by -6 -12 is a point on f. Okay, and we've got another point r is a point on f inverse. Okay. So 4.1. Okay, we want to know, is f inverse a function? Okay, so what do they mean when they ask, is something a function? Well, for a function, you provide one input and you get one output. So how does this work? One input corresponds to one output. Yeah, that's what it means for f inverse to be a function in this case. Another way of writing this is saying it's 1 to 1. Okay, one input corresponds to one output. Now, how do we test such a thing? We test this. We test it using
Vertical line test.
Yes, you got it. The vertical line test. Okay, so let's just draw what this looks like here. Okay, so we've got this parabola, but it's only drawn for the left-hand side. And this picture here shows it as a negative parabola like that, sad face parabola. Okay, we also have f inverse. Let's just draw that in a different color. It looks like this. Okay, so this is f. This is f inverse. Okay, so if we do the vertical line test for f inverse, we see that it satisfies the test because at each point along x, it only touches one point along y. So yes, f inverse is a function. Okay, next question here. Okay, if R is the reflection of point P about the line y equals x, what is R? Okay, so we've got P is -6 -12. We do the reflection about y equals x. Remember, that's just swapping x and y, and we get R. So 4.2. If P is given by -6 -12, then R is given by -12 -6. Okay, we swap x and y whenever we reflect about the y equals x line. Okay, 4.3. Calculate the value of A. Okay, so what was A? We saw A was the coefficient of x squared. Okay, and we see this little bit of information here. P is a point on F. If we know that P is a point on F, we can substitute and solve for A. So P is -6 -12 is on F. So we can substitute. So remember, f of x was given by ax squared. We can substitute this. So the y value is -16. So a, the x value is minus 6 squared. Okay, so we have minus 16 is equal to a times 36. So a is equal to minus 16 over 36. Okay, which makes sense. If a is negative, we expect a sad face parabola. That's exactly what we've got over here. Okay, final question for today. Write down the equation of f inverse. Okay, so let's do that. So we know f of x is equal to minus 16 over 36 x squared. We want to find f inverse, so we let y be equal to this. Okay, now if we want to find the inverse, we have to swap x and y. So x and y get swapped. So we end up with x is equal to minus 16 over 36 y squared. Okay, we can simplify this. X is equal to minus 1/3 y squared. So y squared is equal to minus 3x. Okay, now we need to take the square root of this. So y is equal to the square root of minus 3x. Now you should be thinking, why are we taking the square root of a negative? Well, in fact, we aren't taking the square root of a negative because if we look back at our picture, we know that x is negative. So if we go back here, x is negative. So that means minus 3 times x. If we combine them, the result is again positive. Okay, but we need to remember here, we were looking at the negative portion of this function, okay, because the y value is below. Okay, so when we're doing our square roots, remember we need the minus sign there. Oh, sorry. I made a little typo here. Sorry. It's not 16 here. Sorry, this is minus 12 throughout. Sorry, let me just correct that here. Sorry, wherever I put the 16, my apologies. That's actually minus 12. Okay, there we go. Okay, so we need minus square root of minus 3x. Remember, that's not a problem because x is negative. Negative times negative is a positive. So there's no problem there. However, we do need to put the minus sign in front here because we're looking at the negative branch of this f inverse. Okay, are there any questions about this? Okay, if you do have any questions, please just put them in the chat and then we can have a look. Okay, so sadly we are out of time. So if you do have any further questions or anything you would like us to take a look at, please forward that to the email. My colleague will post the email address again. Okay, so any of your finance queries, anything like that, please post it to the email. We will get to it promptly. Okay, so just a reminder about the next session. The next session, session 3, will be on Saturday, the 6th of November, again from 9 to 12. Okay, there we will be going through paper 2. We will be doing the analytical geometry, the trig, your trig graphs, general solution, all of that fun stuff. And then lastly, the circle geometry. the Euclidean geometry. Okay, so that's the plan for session 3. Okay, but in the meantime, if you have any questions about paper 1, please just send us an email. Session 4, we're not too sure about session 4 yet. You will be notified about that. Someone's asking us for tips. I think that's a great idea. At the end of session 3, I will go through any tips that I have for you. Okay. Okay. Recordings. Yep, my colleague will post the link to the recordings as well. Okay. So thank you so much for joining us. I hope you learned something and I hope this was useful. I look forward to seeing you in session 3. And also look forward to seeing all of your emails as well. Okay, thank you very much for joining and I will see you next time. No problem, happy to help. So there's the link again. Please copy it down. Okay, and also the email, please copy that down as well. No problem, happy to help.
Thanks, Brendan.
Sure, no problem.